right? त्यो त मसँग वर्षौंको experience, probably also evolutions, right? Generations को experience is there. And then कान मात्रै हेर्यो भने पनि होइन, थुतुनो मात्रै हेर्यो भने पनि होइन, फर मात्रै हेरेर पनि होइन. I don't know, like, if somebody asks me what the difference between a dog and a cat is, it's really hard to explain. But give me a picture of a dog and a cat and I'll recognize it every single time. And so त्यस्तो codify गर्न गाह्रो, like things we knew was right but we couldn't explain like how. So with data, the computer started to learn itself. And then suddenly a lot more avenues for applications opened up. And that was through machine learning. So a lot of AI applications that are commercialized are along those veins, right? Image recognition, image captioning, language translation, language generation. And so like most things that were difficult and then suddenly become possible due to machine learning. So AI and ML सँगै भनिन्छ, but ML is a small subset of AI.
Okay, interesting. So with that, like when you started working on Ford, like what was your role like as an intern when you worked there?
So as an intern, I was working on basically an evaluation system. So self-driving car ma अहिले पनि, right? One of the biggest problem is 3D recognition, because like images that we use with cameras, they have a 2D thing, and then because the depth axis depends on the focal axis, there's an inherent, like it's impossible, right? Without two cameras, you cannot figure out the depth. It's physically impossible. And even with two cameras, there's a lot of like noise factors which affect it. And then the further the object is, it's hard to recognize the depth. And so a lot of cars use laser scanners, LIDAR sensors to do that 3D object detection. But lasers are expensive. LIDAR scanners are extremely expensive. Google car use a laser scanner when I was starting on this project costed, I think about $200,000-$300,000 one device.
Okay, LIDAR on laser on
LIDAR. त्यो टाउकोमा यता ठुलो छ नि. अहिले त they manufacture itself, that the cost has come a little bit down, but at that time, you know.
When was that?
2016.
16. Because all the even every smartphone, like iPhone, they have LIDAR scanner.
Yeah, like so laser scanner by itself, त त्यो हामीले projector मा use गर्ने laser pointer पनि it's a laser scanner, हैन. तर car may use it's a rotating object, and then you have multiple beams to get the resolution you need.
So it's not like one direction, it's like in multiple directions.
It's like 360 degree with like, I think they used to have 1 centimeter resolution, which is why it was expensive. And so my project was, there were other startups trying to build a cheaper laser scanner. And so my project was to basically develop algorithms to compare them and then see if we can get the cheaper scanner
working
comparable to the more expensive one with like software.
That's nice. So how did that go?
That was interesting because we're working closely with a startup, right? So the laser scanner itself nay finished product thena. They were trying different patterns to scan, because one of the ways you can counter resolution is like if what you're doing is scan really fast. And so instead of like one beam scanning just one point, if you do it really fast and use the same beam by like moving the parts to scan multiple points, then एउटै laserले धेरैवटा laserको काम गर्यो नि त, and that's one way to bring the cost down. But then त्यसलाई descramble गर्नु is the software ko part, right? Now if you had a one beam, then decoding it is easy, but if that beam goes in a Z pattern, then you have to decode it. And so there's a timing issue. Like now decoding takes a lot longer, which is time sensitive. So we were working with the lasers company to figure out like what scanning pattern would be best, how many beams is like mandatory, and what we can subscribe. So there's no like, oh, we succeeded. It was more like it was an iterative process. And then because the company itself was a startup, they had their own funding struggles, employee struggles, etc., etc. So it was, an interesting project. And then I think what we discovered was they had an 8-beam laser, 16-beam laser, and a 32-beam laser. And then the expensive one I was talking about was a 64-beam laser.
Mm-hmm.
And so we were like, okay, 8-beam, not possible at this time. 16, we could do it, but only for like low-speed applications. And then we at least required 32 for high-speed applications. I think that was like my conclusion.
Conclusion.
Given the state of technology at the time.
Uh-huh.